Okay, so like have you ever been scrolling through like your phone or whatever,
Uh-huh.
and you see a headline that just makes you go, "Wait, what?"
Yeah,
Like some wild claim about,
all the time.
like how left-handed people live longer or
Right,
something.
yeah, yeah,
How
totally.
do we even know if that's true?
Well, that's a great question, and it's actually something we're going to be diving into today.
Perfect.
We're talking about covariance and causality and how to really figure out what causes something to happen.
Okay, I am intrigued.
Because let's be honest, sometimes it feels like anything can be related to anything else if you look hard enough.
Oh, absolutely. Like correlation versus causation, I
Mhm.
feel like that's something we hear all the time,
Yeah,
but it's kind of hard to like really grasp.
it is, and that's why we're going to break it down.
Okay.
So let's start with covariance.
Okay.
Basically, it just means two things are related in some way.
Okay.
They can both increase together, decrease together, or like one goes up while the other goes down.
Okay. So if I'm understanding this right,
Yeah. It's like if I study more and my grades go up, that's
positive covariance,
yep,
exactly.
positive covariance.
They're moving in the same direction.
Gotcha.
But say you start binge watching a show and then you're not sleeping enough,
Uh-uh.
that would be negative covariance. They're going in opposite direction.
Okay, that makes sense.
And you know what's really cool? We can actually see this relationship
Oh.
visually with scatter plots.
Okay, yeah, I kind of remember those from like way back in stats class.
Yeah, exactly. So like imagine you plot like your daily steps
Okay.
on one axis and then your mood on the other axis.
Yeah, okay.
If you see a pattern like more steps, better mood, boom, that's positive covariance right there.
Okay, so we can like literally see it.
Exactly.
Okay, that's helpful.
Visualizing it can really make it click.
Yeah.
But here's the thing, and this is where it gets tricky.
Okay.
Just because two things are correlated
Yeah.
doesn't automatically mean one causes the other.
Right, right. Like back to that whole correlation doesn't equal causation thing. Exactly. And there's this classic example. I love using it.
Okay.
Ice cream sales and crime rates.
Okay.
They both tend to go up in the summer, right?
Makes sense.
But does that mean eating ice cream makes you commit crimes?
I mean, I hope not.
Probably not, right? There's
Yeah.
likely something else going on there, like maybe the heat making people more agitated and also, craving a cold treat.
Right. The heat is the real culprit.
Exactly. And that's where things can get kind of messy because you see, misunderstanding this whole causality thing
Yeah.
can lead to some, well, not so great decisions.
Like what?
Imagine a company, they see that when they spend more on ads on a specific platform, their sales go up.
Okay. Seems logical.
Right, so they think, boom, let's pump even more money into that platform. But what if
Hmm.
there's a hidden factor?
Hmm.
Maybe it's a seasonal trend or people are just, buying more in general.
So they could be totally misinterpreting the data.
Yeah, and end up wasting a ton of money on something that's not actually the cause of the sales increase.
Okay, so how do we avoid making those kinds of mistakes? How do we know for sure if something's actually causing something else?
It's like detective work, right? You need to find the real culprit.
Yeah.
So first, we need something called temporal precedence.
Temporal precedence. Okay, what's that?
Basically, the cause has to happen before the effect.
Make sense?
Right. You can't say watching a scary movie made you eat a whole bag of popcorn if you already had the popcorn before the movie even started.
Okay, yeah, that makes sense.
You got to establish the order of events.
Right. Gotta have that timeline straight.
Exactly. Next, we need a mechanism.
A mechanism, like a how-to guide.
Basically, yeah. There needs to be a plausible explanation for how one thing leads to the other.
So it's not just enough to see a connection.
Hmm.
We need to understand how it works.
Exactly. What's the chain of events? And finally, we have to rule out those sneaky confounding variables.
Okay, confounding variables, now those sound like trouble.
They can be. Imagine a study says people who drink coffee live longer.
Okay, coffee lovers rejoice.
Right, sounds great. But what if coffee drinkers also, I don't know, tend to exercise more or have less stress?
Uh-huh.
Those could be confounding variables, meaning they're actually influencing both the coffee drinking and the lifespan.
So it's like trying to find the real signal through all the noise.
Exactly. And that's where things like statistics come in.
Okay,
There are tools like regression analysis that can help untangle those relationships.
so we can like measure how strongly things are connected.
Yeah, but even the fanciest stats can't prove causation on their own.
Oh, really? So if stats can't prove it, how do we figure out true cause and effect?
That's where experiments come in.
Okay.
The gold standard, the real MVP of proving causality, is the randomized controlled experiment.
Fancy name.
It's like a scientist's ultimate detective tool. You randomly assign people to different groups.
Okay.
Let's stick with our coffee example. One group drinks coffee, one group doesn't.
Okay.
This helps minimize those confounding variables.
So it's like a controlled environment where you can really see what's going on.
Exactly. Now, I know this might seem pretty technical,
Yeah, that's it.
but here's the thing. Understanding this stuff can actually help you in your daily life.
Okay, that's what I was hoping for, some real-world application.
So think about all those health claims we see everywhere.
Like, this supplement will make you a genius, or whatever.
Exactly. A lot of times, those claims are based on correlational studies, not controlled experiments.
Ah, gotcha.
So next time you see a headline like that, channel your inner scientist. Ask
Yeah.
yourself,
Okay.
what kind of study was this? Did they really prove something causes something else, or is it just a correlation? Are there other factors that might be playing a role?
So basically, don't believe everything you read.
Be a critical thinker, question everything.
I like that. It's like having a superpower, seeing through all the BS.
Exactly. And this isn't just about health claims, it's about everything.
Oh.
Political stuff, economic predictions, even personal decisions like where you want to live or what career you choose.
Oh.
Understanding covariance and causality helps you navigate all kinds of information and make choices that really align with what you want.
I'm telling you, this deep dive has been seriously eye-opening.
I'm glad to hear that.
I feel like I have a whole new way of looking at the world now.
That's awesome.
And on that note, I have a final question for you and for anyone listening out there.
Hit me with it.
What seemingly unrelated things in your life might actually have a hidden connection? What correlations have you noticed that you'd be curious to dig into further? Keep those questions in mind. And remember, sometimes the most fascinating discoveries are right there in front of us, just waiting to be uncovered.
I love that. That's a great takeaway.
It's all about staying curious and thinking critically.
Right. Exactly.
And that's a wrap for today's deep dive.
See you next time.
You've been listening to the Learning Podcast, a production of Metanesta. Remember, learning is a journey, one step, one insight, one skill at a time. We'll see you next time. Keep learning, stay curious, and as always, be awesome.